Hello. Okay, so here's what I did with this part of the textbook. So I have Newton's law, the the one thing that's literally universal because it makes most of the ODEs basically, or the basic ODEs that you start off with. An object that will not change unless force acts upon it in reference to inertial frame, that thing, and then F equal ma, and then the object's equal and opposite shenanigans. Anyway, yeah. So first of all, we're gonna list out the basic forces, just because I realized that there's some basic forces that are not really intuitive for you to understand. Really, if I were to give you, I don't know, this stack of paper, it says, uh, what was the force that makes it go down? Uh, yeah. It would be gravitational force, right? And then it'll be a F, and then the normal force would be the reason that it doesn't keep on going down when it hits the table. And then the frictional force is, stopping it from sliding everywhere. And then there's a magnetic force, and then all the other stuff. But the magnetic force and the electric force, that's a little more intense later on. We'll focus on them a little later on. I as a I'm not really. I mean, I do. There's some questions on electricity, but I'm not really focused on that yet. That's more controls, which I haven't done much of yet. That would probably be more. Actually, I'm doing one class on it this quarter in winter. Um, well, we'll see how that turns out. Uh, but what I'm trying to say is that those classes are from the you know not in regular mechanics, so I didn't really put it in here. Um, Mainly due to it being a little bit more confusing and a little bit more like a headache to deal with. Um, so the most basic force, I mean, these can be headaches if you do it, if you think about it, because when you get moment of inertia and get a whole entire different system, and you have a system interacting with another system, it becomes complicated and it becomes confusing. But for now, we're doing basics, so it wouldn't really matter. We'll say, on the other hand, that we'll revisit mechanics again. We're doing, excuse me, we're doing physics mechanics, basically one-on-one stuff, and then we're going to visit again when we do full-on dynamics again, um, because uh, yeah, uh, most of the electric stuff I'll have more on that next year because I'm going to take more classes on the control side later on. Uh, but for now, I don't have much on that shenanigans yet. I have the textbooks for it. I've been reading them, but they're not really that helpful when you don't know what the shit is going on. Um, Anyway, there's a book. So I love this because I'm starting off with a bunch of books on here, and the system is what you decide the system to be. You could individually make different systems, and each one of them, like one, two, three, four, five, uh, of them, yeah, five of them, and then you can show the interaction with all of them and figure all of that out. Like this book's over here, this book's over here, and this book over here, and interaction with them. But I can label it all in a group to equal m. Okay, so we'll continue again. Sorry about the noise. Um, so we have this. So we start with basics where we do F equal Fn plus Fg. Notice that they're not really unknowns. There's when you make ODEs later on, there's some other variable inside, but this is basically just plug and chug right now. So this is why we could do Fn equal Fg because it's equilibrium. It has to equal to 0. Therefore, it's 12 kilograms multiplied by 9.8. But really, you round that 9.8 to 10. It won't really matter in the long run. 120 newtons of force is the F normal force battling the gravitational. We know the gravitational by measurement. How we know is that you just you can measure with a light or uh, laser scanner or something, and then you can figure it out. Okay, another thing we did is next is, oh yeah, as you can see, this looks so ugly earlier a long time ago. I changed this to this to make it cleaner. So when there's multiple and you're interacting with different systems, this is what happens. And because you're getting two masses here and interacting with each other is what you're kind of doing when you're doing Earth onto human and then human onto Earth. As you know, Newton's third law has to make them equal to each other. We'll do a lot more of these later on with way more confusing circles in M1 and M2. In this case, it's very simple, just getting the vibes of it. Next thing is I did do this question. I remade it from this horrible thing, and this can all be deleted. I was literally typing out and screenshotting it. Um, yeah, that's how I do it usually. I you see these things there. I don't really like it that when I do handwriting anymore because it looks awful. So I like to type it all out and then screenshot it individually and put it in here like this. You can kind of see what I did. Um, yeah, and I didn't like how I put like 1.6, I believe. I rounded up. I think 1.58 is more cleaner because honestly, it's due to significant figures, but let me just make it so that it's three significant figures no matter what. I don't really like significant figures too much because that's only valid for mostly physics people that really needs that. For engineers, they don't really give a shit. So yeah. So now I guess this is a new value, so make it clear. Also, the statement about that question was a little unclear too. So we start from rest, we go to point one, and we drop at point two. Pretty clear question. It really isn't that difficult, in my personal opinion. If you get things right, if you I think I forgot to do something. I just realized I should have given the uh, x underscore one plus v underscore one underscore I believe it's I and t, and then this would be the thing I put in there because there's no acceleration to it. I should probably put acceleration to it. I know I should have. Okay, let me just put that in there. 1 divided by 2 a t square root of 2. And then we'll just say that the a cancel out because there's no ax over here. And then we probably want to showcase everything a little bit. Yeah, you know, and that looks horrible. Let me do that again. The I needs to show up. Let me see if the I shows up on that one. No, it made the one look a little bit horrible. Let me try this again. Let me plus it a little bit. I'm screenshotting right now, which is why it looks kind of bad. Um, yeah, it looks pretty clean. What I'm going to do with that is basically plug into here and make it smaller. And then we're just going to move around. Oh, I forgot that's one big. Do I really need this? No, but I like it there. It shows something. Where did I put that? Okay, here. Go like this. And then save. And there we have it. I don't like that either. Something feels off with that. Yeah, okay. I guess we could move this over here a little bit. I mean, this can be smaller, honestly. But this, I think, needs to be bigger, actually. Do I really need this? No, I mean, we could just put it in the top, right? To make it look like it's part of everything, I guess. I like this over here. And I like this over here. And I like this kind of over here. Kind of like, oh, we could do it like this. Yeah, totally, totally. And then we could do it like this. No, it looks pretty good. Now, I'm debating if I should do it for all the other ones. This one, I'm going to have to use overleaf to figure out all the forces and all the matrices. It's always a pain in the ass to do it. Oh, let me just delete that. It's no longer a question. Oh, I'm going to have to remake this definitely. No, definitely going to have to remake that shit. That looks awful. What the fuck was I thinking? Um, yeah, and then more system stuff. We'll do more system stuff. the basics of mechanics. Honestly, it's not hard. It's just a lot of mechanics. The forces balance, and getting zero is the first step. When it doesn't equal zero, is then you have to strictly use ODE mostly to figure out what the hell's going on with the middle part and getting the time. Yeah, it's not really that much of a pain in the ass. Actually, the give out is pretty easy. You can figure it out very easily and get time easily. Anyway, when I was starting to do this in the beginning, it was harder. Anyway, yeah. So this is what I'm gonna kind of do. I'm gonna make it cleaner. Generally, I like it clean. This looks as clean as it can get. Yeah, yeah, I think so too. Yeah. I like the car also I made over here. It's basically a lot of different rectangles, and yeah, I'm gonna stop here. I'm yapping. I don't think I have anything else. Let me just stop here. Oh, I forgot to mention something here actually. Um, if you look at the force diagram over here, this is an awful question because I put 89 degrees. So I'm gonna have to redo all this. This was a bad question over here. So I'm gonna just change that real quick.